So hey everybody, in this video I'm going to solve few numericals related to the application of integration and differentiation. Basically it's a part of calculus. Calculus means study of change. Integration and differentiation, they both are opposite of each other. Integration means like adding up, summation. Differentiation means it's like to divide, to make things small. Okay, they are opposite of each other. So let me write down the formula for the differentiation. Say x raised to n, I want to differentiate it with respect to x. In case of differentiation, power comes in front and its value will decrease by 1. So n will come in front and its value will decrease by 1. For example, I want to differentiate x raised to 5 dx by with respect to x. 5 will come in front and its value 5 minus 1, it will become 4. Now there is more about differentiation. In this video I can't explain all. I'm going to explain things in in short here. We'll learn more about it during the lecture. So now let me talk about integration here. This is the symbol of integration. Say I want to integrate x raised to n. Here integration means adding up. So if power will increase by 1, here we reduce power by 1, here it will increase by 1 and same number will come in denominator. Say example, I want to integrate x raised to 5. This will be like x raised to 6 and 6 will come in the denominator, same number. Plus c, constant of integration, but I am not going to talk about it here. Like I said, there is more about integration and differentiation that we will learn during the lecture. Now let's solve few numericals. Let's begin with question number 5. Okay, time dependent position s of a body moving along a straight line path is given by the equation s is equal to pt. S is equal to pt plus qt square. P and q are constant. State whether the body is moving with uniform velocity, uniform acceleration, both a and b, none of these. So we need to differentiate this equation, and after differentiating it with respect to time, we'll get the expression for velocity, and then we will analyze that equation and we'll select the correct option. So let's find out the velocity first. Let me differentiate this equation with respect to time. Pt plus qt square. Alright, so I'm going to differentiate it. So now here the constant term, we take it out. P is constant here, so let's differentiate dt with respect to time. Okay, q is constant, let me differentiate t square. Now this term will get, this will become 1 here, dt by dt, that will become 1 here. Now q, we know that power will come in front, and here the value of t will decrease by 1. Alright, so this equation is p plus 2qt. This is the expression for velocity. Now here as you can see, p is constant, q2 is constant, q is constant, only time is variable. So if time is increasing, velocity will also increase. So it's a uniform accelerated motion. We can also compare it with first kinematical equation, u plus at. So as you can see, the equation is looking similar, and it's a expression of uniform acceleration. So this option is correct here. So you know what, most of the time such equation will be given for the position of a particle changing with time. If you differentiate it, you will get the expression for velocity, and then analyzing the equation, we can say whether it is uniform motion or non-uniform motion. So now let's move on to the 6th one. I hope you understood this part here. Let me erase this part. Okay, now let's move on to the sixth one. Position, expression for the position is given like it was given in the previous numerical. If you differentiate it with respect to t, we'll get the expression for velocity. Now here we need to find out the initial velocity of the particle. So what is the meaning of initial velocity? Initial means when time was 0. Alright, so let's find out the expression for velocity first. Let me differentiate this equation with respect to time because it's a function of time. So 6 is constant. Let me differentiate t square. 5 is constant. T will get differentiated with respect to time. Let me change the color here. Okay, this 2 will come in front. 6 into 2 and its power will reduce by 1, so only 1 t will remain here and this will become 1. Alright, so equation is 12t minus 5. Now we need to find out the initial velocity. Initial velocity when time is equal to 0. So if I put t is equal to 0 here, this part will become 0 and I'll get minus 5 meter per second. So this option is correct here. So you need to differentiate the equation and then you need to understand the statement. So there are two parts basically, differentiation and then understanding the statement, and then you can solve such numericals. Now let's move on. I hope you have understood this part here. Let's move on to the next numerical. Okay, 22. Okay, check this one. Displacement x of a particle. This is the expression for displacement. We need to calculate velocity at 2 seconds, acceleration at 4 seconds. So if I differentiate it one time with respect to time, I'll get the expression of velocity. And what is acceleration? dv by dt. Alright, so let's differentiate this equation with respect to dt. 3 minus 5t plus 2t square. 3. Alright, what is this? Okay, 3. Okay, wait a second. Differentiation of 3 with respect to time. It will be 0 actually, constant. You cannot differentiate constant. Its differentiation is 0. It doesn't change actually. Alright, 5 dt by dt plus 2 dt square by dt. So this will become 0. Differentiation of constant is 0. Here it will be minus 5. This will become 1. This power will come in front, 4t, and its value will decrease by 1. So only 1t will remain here. So this is the expression for velocity. Alright, we have got the expression for velocity. Now we need to find out velocity at t is equal to 2 seconds. So if I put the value t is equal to 2 seconds here, it will be like 4 into 2, 8, and this will be 3 meter per second, right? So this is the expression for velocity. Now let me solve the second part of it, acceleration. So how can we get the acceleration? We need to differentiate this equation with respect to time. Let me change the color here. So if I differentiate v with respect to time, let me differentiate this equation. So differentiation of this constant will be 0. Directly I am going to differentiate this part. 4 will come out and this will be 4 meter per second square. Okay, I have directly done it. Differentiation of minus 5 will be 0. You cannot differentiate a constant. Its differentiation is 0. It means it's not changing. Differentiation means differentiation is all about changing. So constant doesn't change, so उसका differentiation 0 हो जाता है. 4 will come out, dt by dt that will be 1, so 4 meter per second square, that is my answer. Alright, so t term तो बचा ही नहीं, तो acceleration at t is equal to 4 second वो constant ही रहेगा basically, because here the acceleration doesn't depend upon time, so it means it's constant. Alright, so I hope you understood the solution here. Let's move on to 23rd. So let me erase this part here. Alright, check this one. 23rd. Displacement expression is given. Let me differentiate it with with respect to time. I'll get the expression for velocity. So first part is easy generally. 2 by 3 t square plus 16t plus 2. So here minus 2 by 3 is a constant. Let me take it out. 16 is constant in second term. Let me take it out. And differentiation of constant is 0. This part will become 0. Let me change the color here. So we know that this 2 will come in front and its value will decrease by 1. So only one t will remain here. This will become 1 and this will become 0. No need to write that. 2 into 2, 4. So 2 into 2 minus 4t by 3 plus 16. This is the expression for velocity. Okay. Now further it is mentioned how long does body take to come to rest. We need to calculate the time. How long means we need to calculate the time. Does body take to come to rest? Rest means final velocity will be 0. So let me put 0 here, and after putting 0 and solving it, I'll get the expression for time. So if I solve it further, let me solve it here. Let me bring this term on this side. So this will be 40 by 3, 16. So 4, so t will be, bring 3 on this side, that will be 12 seconds. So you know what, first part is about differentiation, second part will be about understanding the statement. So here how long means we need to find out the time. Does body take to come to rest means final velocity will be 0. So put the 0 over here in place of velocity and only t will remain in the expression. So it means we can find out the expression for time. Now these numericals were related to differentiation. Let's move on and let's solve one related to integration. 25th वाला is related to integration. अच्छा उससे पहले एक और है ये particle moves along the straight line. Okay, expression for displacement is given, position is given. Okay, find out the velocity. इसको एक बार differentiate करेंगे तो velocity मिलेगा. And further it is mentioned when acceleration is 0. इसका मतलब यहाँ पे acceleration भी निकालना है. So see, I'm directly doing this part here. dx by dt. Let me directly solve this part here. So 3 power will come in front and its value will reduce by 1. 6. अब t square का differentiation, 2 will come in front, its power will reduce by 1. Only one time t will remain. 3 is constant, dt by dt will be 1 and 4 का differentiation 0 हो जाएगा. तो मैं इसको नहीं show कर रहा हूँ. Okay, so I have directly differentiated this part here. I hope you understood that part now. Further it is mentioned acceleration. अब acceleration इसको differentiate करते हैं. Let me change the color here. Acceleration भी निकालना है. Acceleration is dv by dt. So let me differentiate this part here. 3 is a constant that will come out. Differentiate t square, 2 will come in front and its power will reduce by 1. 2 minus 1, 1 will remain here. 12 will come out, dt by dt that will be 1 and differentiation of 3 will be 0. So only this term will remain. 6t minus 12. This is the expression for acceleration. And this is the expression for velocity. Now, further it is mentioned, find velocity when acceleration is 0. तो acceleration 0 put करेंगे तो हमें वहाँ से time का value मिलेगा. Let me put 0 here. 6t minus 12, and here if you solve it, bring 12 on this side, the value of t will be 2 seconds. Means I need to put the value here. So let me solve it here. 3 2 square minus 12 2 plus 3. 2 2 4 12 minus this will be 24 plus 3. This will be minus 12 plus 3, and that will be minus 9 meter per second. This is the expression for velocity. ये meter per second होगा, minus 9 meter per second. So you know what, differentiation and understanding the statement, there are two parts. Now let's move on to the 25th. It is related to acceleration. I hope you understood this part here. Let me solve the 25th one. 25th is related to integration. We know that acceleration is dv by dt, right? Okay, check this one. Expression for acceleration is given. If the particles start out with velocity v is equal to 2 meter per second at t is equal to 0. This is initial velocity. Particle is already having velocity. Find velocity at the end of 2 seconds. We need to calculate the final velocity. So bring dt on this side. If I arrange this equation, a dt, this will be the expression for velocity. If I integrate both the sides, I'll get the expression for, oh, I just made a mistake here, sorry, my bad. It's bring dt on this side, so it will be a dt. Acceleration is a function of time. Integrate both the sides. Now if I integrated both the sides, I'll get the expression for velocity. I need to calculate the velocity here. Also one more thing, here the limit is given, t is equal to 0 second to 2 seconds. So let me put the value here, 0 to 2 on both the sides, dv. Here 0 to 2. A, what is the formula, what is the expression for acceleration? 3t square minus, sorry, plus 2t plus 2. Alright, so here on this side it will be like velocity. Alright, now 0 to 2 means initial velocity, final velocity. Alright, so wait a second, I'll not put 0 and v2 and 0 here. Wait on just a second. Let me solve this part first. Bring 3 out, is a constant. Integrate t square. Let me bring 2 out. Let me, oh sorry, my bad, I just made a mistake here. Who will write dt? Who will write dt here? Dt was there already. Dt plus second 2 will come out and t is there. Integrate t. Then here 2 will come out and only dt will remain. So now let me change the color here. On this side, let me write it like final velocity when t was 2 seconds and minus initial velocity when time was 0 seconds. So 3t, power will increase by 1, 2 will become 3, same number will come down, and into the bracket 0 to 2. I need to put the limit as well. Okay, 2. Here the power is 1, it will become 2, same number will come into the denominator, 0 to 2. 2, here nothing is there, so only t will appear. Integration of dt is t. Alright, so 0 to 2. 3 will get cancelled here. Let me cancel it out. 3 2 2. Further t raised to 3, 0 to 2, t raised to 2, 0 to 2, 2, t 0 to 2. Now all I need to do is put the limit into this formula. put 2 in place of t, so 2 का क्यूब कितना हो जाएगा 8 माइनस 0, तो वो लिखने की ज़रूरत नहीं है. ओके, put 2 here, 2 raised to 2, that will be 4 plus 2 and put 2 here. माइनस 0 करते, बट क्योंकि ये माइनस है तो मैं उसको शो नहीं कर रहा हूँ. ठीक है, 2 to 4, right? So on this side I'll get this will be 16. All right, now check this one. On this side I had final velocity minus initial velocity. Initial velocity का value already 2 meter per second दिया उन्होंने. So if you bring this 2 on this side, here it is minus here. If you bring it on this side, 16 plus 2, 18. So my final velocity will be, let me write it here, 18 meter per second. And that is my answer. So you know what, looks like it is quite lengthy. It's not lengthy actually. Once you practice these numericals, it will become easy for you guys. तो पहले से उसको इंटीग्रेट करना है, एंड इंटीग्रेशन के लिए आपको फार्मूला पता होना चाहिए. एक्सेलरेशन का फार्मूला dv by dt, bring dt on this side, and acceleration is a function of time. Integrate both the side, and that's it. Now here the limit is given 0 second to 2 seconds, so we need to put the limit here as well. dv, integration of dv is v. Let me write it here. Integration of dt is t, integration of dx is x. We have already seen these things during the lecture. Okay, now here we need to put the limit here. Velocity at 2 seconds, velocity at 0 seconds. So this is how I have shown it. Final velocity I needed to calculate at 2 seconds, and this is the initial velocity at 0 seconds. So you can also call it v2 and v1 and v2, but 0 second is there, so let me call it v initial, and this is v final. Okay, v initial is given 2 seconds, so I have put 2 meter per second, so I have put 2 here, and solving this side will give me 16. So 16 plus 2, 18 meter per second. I hope you understood this part here. थोड़ा lengthy था, but you know, once you practice, these things will become easy for you guys. So I hope this video will help you guys. Do comment and let me know. Thank you very much.